This is Josh White with JW Math Tutoring. In today's video, I'm going to cover 9 problems from the September 2025 Digital SAT Math exam. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Before I begin working through these 9 problems from the September 2025 Digital SAT Math exam, I just want to mention a couple things that I mentioned at the start of all these videos. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there'll be a link to a PDF file which has all of these problems in it, both in the description of the video and in the pinned comment as well. Third, I've tried my best to recreate these problems based on what has been self-reported on Reddit and other places. So keep in mind that if you had recognized one of these questions from your exam, the details might be different, the setup of the problem might be slightly different, the problem may have been multiple choice on the exam, whereas I'm doing it as a free response question. So just keep that in mind, that I've tried to make them as realistic as possible, but there could be minor or possibly even major differences, based on the just the information that I've been able to gather. Lastly, because there's so many tests basically in a short time period, you have August, and then 3 weeks later it's September, and then 3 weeks later October, and then November and December. For the upcoming months, I'm only going to focus primarily on new questions. So there's going to be fewer total worksheets and fewer total problems, but that's primarily because I'm not going to be going over and including like repeat problems that we have seen before. So if there are questions that are repeats, that have showed up on previous months, check out my older videos to find out how to do those. And at some point, I will eventually post kind of like a master list, which shows, here's all the available questions, here's the specific questions on this worksheet, this problem number, and so on and so forth. All right, so with that being said, and last thing too, if you have any questions or comments or alternate solution methods, please do feel free to leave them in the comments section below. Okay, so with that being said, let's go ahead and get started here on question number 1. This was a very popular question that came up, the one about like vitamins and so many ounces of cheese and so many ounces of tuna. And essentially you have to construct an equation that represents the total ounces of this vitamin that you would get for eating, let's say, X ounces of cheese and Y ounces of tuna. All right, so we know that the basic relationship, okay, for cheese, it's 3 ounces of cheese to 1 ounce of this vitamin. And then for tuna, it's 1.2 ounces. I'm just using OZ to abbreviate ounces to 1 ounce of the vitamin. Okay, so really what you have to do here is you have to find essentially the unit factor. And what I mean by that is how many ounces of the vitamin do you get per 1 ounce of cheese or per 1 ounce of tuna? So that's really where you're just dividing, both sides by these values. The reason we do that is because, so this is 1 ounce, this is technically 1 over 1.2, which if we go to Desmos, you'll see that this actually reduces to 5 over 6. So, sorry, the reason we do that is because if you want to find out how many ounces of the vitamin you would get from eating X ounces of cheese and Y ounces of tuna, basically we get the unit amount, the unit conversion factor right here, and then we're just going to multiply that by X. So for example, 1 ounce of cheese, 1/3 of an ounce of vitamins. Now if I wanted X ounces of cheese, right, I would just multiply this by X. X times 1 is just X. And then the same thing over here, you multiply it by X, so that just becomes X over 3. Or, as you can see in this equation right here, 1/3 X. And then similarly over here, if you wanted for the tuna, if you ate Y ounces, you just multiply this by Y, and then you do the same thing to the other side. So you get 5Y over 6, or 5/6 times Y. So the correct answer for this one is going to be letter C. And that's pretty much the only way, at least the main way I can think of to reason through it. If you have another alternate approach, that's fine, leave it below. But this is the main way to kind of theoretically work your way through the problem and figure out what the correct equation is going to be. All right, next let's look at question number 2. So here is a problem involving a sphere. They give you the density, they give you the diameter, and they want you to find the mass. So you should know that the equation to relate density and mass is d equals m over v, or density equals mass over volume. So now we know the density, that's 2.2. Mass, we don't know, that's what we're solving for. What's the volume? Well, we know the diameter of the sphere, lowercase d, is 20, which means its radius is 10. So now we can find the volume just using the volume formula. This is provided on the reference sheet, by the way, so if you forget the formula for volume of a sphere, just go click on reference in the upper corner of Blue Book. So we just plug in 4/3 pi, and then it would be 10 cubed. Okay, so this whole expression, this gigantic number, is what's going down on the bottom here. So what I'm going to do now is just jump to Desmos to basically do all these calculations. So first of all, I'm just going to let v equal 4/3 times pi and then 10 cubed. Okay, it's whatever, 4,188.79. And now, okay, so that would be down here. Notice that the mass is just going to be the density, the 2.2, times the volume, the 4188.79. So all I have to do now is go back to Desmos and just multiply this value, just 2.2 times v. All right, now this question says to round it to the nearest whole number, so that thus our answer would be 9215. Okay, so the mass would be 9,215 grams. You don't have to input the unit or the grams, but 9215 is what you would report as your answer. All right, let's look at the next one. You have a glass. It currently has 22 mLs of water. It's being filled at this given rate. Question wants to know which expression down here represents the volume of water in the glass after t seconds have elapsed. All right, so here is the thing that makes this a little bit tricky. It's 0.08 mLs, milliliters, per every 8 seconds, right? That's basically the rate that it's being filled up at. Okay, and we're starting with 22. So obviously we're going to starting with that, and then we're adding, this, and then times t seconds. Problem is, this doesn't look exactly like any of the answer choices. So what you have to do, what you have to recognize, is that this part right here is just going to reduce to 0.01. And therefore, it's going to be 22 plus 0.01 t, or if you look at answer choice A, you just flip the terms and turn it into 0.01 t plus 22. Now, you could also, I'll just tell you, you could also technically do this by back solving. I won't go through all the work on this, or not back solving, excuse me, picking numbers. Not back solving, picking numbers. So what you would do is you would pick a number of seconds, like say you would pick 16 seconds, right? And you would say, okay, well, it's 22 mLs to start, 0.08 every 8 seconds. So that means 0.08 for the first 8 plus 0.08 for the second 8. Therefore, it's 22 plus 0.16. And then you would go through each answer choice and you would plug in 16 for t, and you would see which one equals 22.16. And just to confirm, it's going to be A. It is not going to be any of the others. So 0.01 times t plus 22, and when I set t equal to 16, notice there I get the answer that I expect if the time is 16 seconds. And you could check the other three, but you'll see that they're, going to be incorrect. All right, let's move to the top of the next page. So here we have a quadratic problem. We've seen ones like this before, but I want to keep this one in just because of the fact of the 1 over 48, the fractional coefficient out front. So quickest, easiest way to do this is knowing that the product of the roots is equal to c over a, which in this problem is negative st over 1 over 48. Now, this can actually be simplified into negative 48 st. So just be aware. You could do that in Desmos. You ignore the st. It's really just negative 1 divided by 1 over 48. You'll see it simplifies to negative 48. So now this is equal to negative 2 kst Notice the ST's drop out, and therefore k is going to equal 24. Now, you could also, this last equation, like when you set it up, negative 48st equals negative 2kst. You could also technically just go to Desmos and do that in regression to solve it for k as well. I will show you. You can also use Desmos entirely for this problem. It is not the what I would consider the quickest or fastest approach, but it is possible, so I'll just demonstrate that briefly. This is a product of roots problem. So this is covered in my ultimate Desmos guide to digital SAT math, basically guide. So if you're interested in knowing more about how these problems are solved, check out the guide. I'll post a thumbnail on the screen showing you which specific video these types of problems are covered in. Okay, so I'm going to do regression to its factored form. It's a quadratic, so I know that there's two intercepts, or two zeros. And now I know that the product of the roots, which would be b times c, is equal to negative 2kst. Except I have to solve this in terms of one letter, and I have to include my element list for x. I have to put a lot of values in it to get it to work. All right, so let's see what's going on here. K, S, and T are constants. They might need to be positive constants, because the problem is S. Notice S is really, really small here. It's essentially 0. So it looks like the problem is happening because of that. So let's see if I do this. Does it work? Okay, so it looks like we just have to add in some type of constraint for S to make it positive in some form, just as long as it's not effectively 0. And there we get the answer of k is 24. Okay, so again, I would describe this as the non-preferred method for this problem, but I still just did want to demonstrate it to show you that it can be done. All right, let's look at question number 5 next. So for this problem, just basic radical equation that we're going to solve here. And essentially, to first show the by hand method, you would square both sides. Okay, and you would get x squared times 11, or 11x squared. Then if you bring everything over to the right, you get 10x squared minus 95x plus 300. At this point, you could just go to Desmos. I mean, I already know how this factors, so I'll just show you. It's much easier to factor it if you pull the common factor of 5 out front. And let me just note, sorry, these signs would need to be switched when I pull them over. It's minus over here, so it becomes plus. It's plus over here, so it becomes minus. Okay, that's plus, that's minus, just checking my work. And it's going to factor as 2x, it's going to be minus 5x plus 12. And let's just confirm that. Minus 5x plus 24x, negative 5 plus 24 is positive 19. Okay, so that checks. This is the correct factorization. So you get two answers. You get x equals 5 halves, or you get x equals negative 12. The only acceptable answer is 5 halves, or 2.5. The reason the negative 12 doesn't work is because if you plug the negative 12 in, you get negative 12 root 11. But underneath here, when you simplify this whole thing out, it's going to simplify to positive 12 root 11, because the 144 underneath here is going to come out as a positive 12, because there's a implied plus sign here. It's a principal root. So therefore, the negative 12 doesn't work. There's only one correct answer. Now, of course, you could just go to Desmos and solve this entire thing in Desmos. So let's just see how we could do that. So I think we should be able to do regression, and that means I need to... There we go. Notice it gives me 2.5. If it had given me the negative, let me see if I can force it to give me the negative value first. Wonder if it's not going to find it, because Yeah, I bet it's not going to find the extraneous root of negative 12 because, of the fact that, like I said, it's not an actual solution. So in this case, since there is only one solution, one, real solution, you can just go to Desmos, type in like this, and get the answer. It's fine. You could also technically graph y equals left side, y equals right side, and look for the intersection if you wanted to solve it that way as well. And that is probably much quicker than, doing all this work out in the factoring by hand. All right, next, let's look at question number 6. So here are a bunch of frequency tables. Which of these will have the highest mean or the highest average? So when you look at these, okay, if you want the highest mean, the highest average, you want the most values with the larger numbers. Okay, you want the least number of values for the smaller numbers. So if you look at that, you should be able to eliminate C and D right away. Okay, C and D have a lot more values of 6 and 7 than 9 and 10. Okay, because the frequency is higher for 6 and 7 in both than 9 and 10, or 8 and 10 in D. So these two can be eliminated right away. So now it's really a question of A versus B. So notice that these frequencies are pretty similar, right? 2, 4, 6, 8, 10, 2, 4, 8, 10. Basically, they're identical, except this one has these extra values at 8, which this one does not have. Now, the mean is going to be higher than 8. The reason I know that by looking at the table is because the values are more, there's more values to the upper end, to the 10, to the 9, than there are to the lower end. If the frequencies were completely symmetric, then the mean would be the number directly in the middle, which is 8. But they're not. Therefore, the mean is going to be higher than 8, which means that the one with more value, more like, say, higher values of the overall percentage, meaning here 18 out of the, 18, but 24 values are 9 and 10. Here it's 18 out of 30 values that are 9 or 10. So this one is going to have the higher mean. However, we can go to Desmos just to check that or confirm it, because we can do the mean of a frequency table. So we just make a table, and we go 6, 7, 8, 9, 10. Okay, and then I'm just going to put in my frequencies. And then down here, I'm going to type total x1 times y1, total y1. Okay, so this is the mean for A, 8.6 repeating, essentially 8 2/3. Here is the mean for B. So I'm going to type in the exact same thing now, except of course I'm going to use x2 and y2, since those are from the table where I typed it in. Notice it's a little bit larger. It is 8.83 repeating. So this just confirms that the mean for data set B is going to be higher than the mean for data set A. Now let's take a look at problem 7 at the top of the next page. So in this problem, you have a certain number of kids at a specific high school that complete a survey. And it basically wants to know what's the largest population that you can generalize the survey to. So this is basically essentially a survey design, statistical methods type question. The correct answer for this problem, it's going to be letter B. And the reason that you can only generalize to this one specific high school is because that's where you chose all the kids from. If you wanted to generalize it to all the high schools in a specific county or all the high schools in a specific state, you would need to randomly select kids from all the high schools in the county or all the high schools in the state. So you can only generalize the results of a survey to the largest population that you chose the respondents from at random. And in this problem, that is the high school. Now, just so you know, if they did not choose them at random, then technically the answer would be A, right? If they were not chosen at random, then you would only be able to generalize it to the kids that did the survey. But because they did choose them at random, that's why we can generalize the results to the entire population of the high school. All right, let's look next now at question number 8. So here you have a problem where an angle has a specific measure 4 pi over 7 radians. And we have another angle which is 18 times larger than this given angle. And they want to know what's the measure of this other angle, but in degrees, not radians. Okay, so this is angle A, 4 pi over 7. So there's two things going on here. First, we have to, let's say first we're going to convert this to degrees. I'm going to do that part first and then do the 18 times part. So the way we do that is we're just going to multiply by 180 over pi. Okay, or basically this would be pi radians. This really has radians up here, and then this is degrees. So the radians cancel out, and notice the pi's also cancel out as well. So right off the bat, answers A and B are wrong because they have a pi in them, and our answer is not going to have a pi in it. So it's basically going to be C or D. Now, you probably recognize it's going to be D because the last step is just multiply this by 18 because we need to make the angle 18 times larger, right? This expression right here is angle A in degrees, and then if we want angle B in degrees, we'll just multiply it by 18. So the final correct answer for this one would be just letter D. All right, next let's take a look at the last problem on this first worksheet, September 2025 problems. Number 9. Okay, this one, if you read through all the text, basically what you have is a picture which is going to look something like this. And there's two different ways you could draw it. I put C here, obviously, is the right angle. And I put B down here and A up here. But you could technically have them switched. Because I drew it like this, that means point K is somewhere on side BC, consider the base of the triangle. And then L is on your hypotenuse right here. You draw this line, and basically these two things are parallel. Okay, we also know LK, or KL, is 21, and AC over here is 63. We're told to find the length of segment BK, so we'll just label this X, and we also know that the area of the triangle is 819. All right, so this is actually going to be a multi-step problem. Essentially, step 1 is using the area and using this side right here, which we could think of as our height, to find the total length of the base. All right, so we know 1/2 times the base, which is side BC, times the height, is equal to the area. So if we go ahead and set up that equation, we should end up with BC equaling 26. Okay, so this entire side length right here. Let's just go to Desmos to confirm. So easiest way I would do this, I'm just going to use B for base, and then it's multiplied by the height, which is 63, and we'll set that equal to 819. Okay, good. So B is 26. Now, we can set up a proportion with similar triangles to solve for the length of X. So essentially what's going to happen is, we have these two sides, and we'll just fill this in now as 26. The two yellow sides are sides in the large triangle. Then the two red sides are sides in the small triangle. So I'm going to set up a proportion of, okay, X, small triangle, base, over 26, large triangle base, equal to 21, small triangle height, over 63, large triangle height. Now, you could solve this up by hand, or let's just go back to Desmos and just do it that way. Just move this to the side. So basically I want, instead of X, whatever, I'll just use X1, that's fine, over 26. I could have typed B there, 21 over 63. Okay, so X1 comes out to 8.666667. So let's type it down here. Let's convert it to a fraction. Okay, so we get 26 over 3. So that is the correct answer for BK. So you could enter it as 26 over 3. You could enter it as 8.666. That's if you truncate the decimal, or you could enter it technically as 8.667. That's if you round the decimal. But all three of these answers would be considered correct for this problem, would be accepted. All right, so this was, those are 9 problems. This is the first September 2025 Digital SAT Math official exam worksheet problem set. If you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments, please do leave them in the description of the video below, or alternate solution methods as well. Second, be on the lookout for the second worksheet, second video, which should be up shortly as well. There's probably only going to be 2 this time because I mentioned earlier I'm really only focusing on the new questions, not including any repeat questions. And lastly, if you're looking to improve your skills with Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It's over 5.5 hours of tips and tricks and instructions and 65 practice problems to help you ace the digital SAT math section.